Hi, I'm Lexi.
I'm Megan.
I'm Malay.
I'm Tony.
And we're the Fountain Four.
Engineers rely on the design cycle to aid in the building process and ensure what is being created will work effectively. The first is to define the problem, then search for solutions, narrow and select, build, and test and check. In creating our fountain, we had to go through this process several times. The first step of the cycle is to define the problem. For our project, we had to build a fountain within the budget of $40, where the water flowed against gravity and incorporated an engineering component such as having the water actuate light or movement, or create a fountain that doesn't use a pump. After we considered the previous criteria, we needed to search for solutions and then narrow and select them from these choices. First, we needed to decide whether we should make a traditional fountain with a pump or Huron-style fountain that doesn't use a pump. We decided to build a traditional pump with the pump because it opened up more aesthetic design ideas. For our aesthetic design, we brainstormed either having water overflowing with the center of a tree trunk or water sprouting out of the mouth of a wolf. We thought the trunk would have more potential. Aesthetically, we wanted to create a serene atmosphere, so we decided to have water overflowing from a tree stump to represent new life. We could use leaves, flowers, rocks, and lights to enhance this design.
After we created our plan, it was time to enter the prototype process. To build our fountain, we used a hollow stump and placed the pump underneath. In our original design, we wanted the water to spout out from the center of the stump by drilling a hole for the tubing to go through. However, we then realized that since the stump was ceramic, there was a major risk of cracking the tree stump if we attempted to drill it. At this point, we entered the test and check stage of the design process. So we considered other options like wrapping the tubing around the top of the stump and cutting small holes into this tubing for the water to flow out. This idea didn't work because the water flow was very minimal and the direction at which the water spouted out was not consistent. Finally, we decided to try creating a steady stream of water arching over the trunk. This idea worked great, so then we moved on to creating our water wheel. We decided that instead of buying a water wheel, we could create our own using a plastic bottle cap, the bottom of a plastic container, a cardboard mac and cheese box, and hot glue.
We cut the paddles out of the plastic container and glued them around the plastic bottle cap. We used a cardboard box to cut out the backing of our wheel and covered it in hot glue to make this piece waterproof. We drilled a hole through the center of the plastic top for the axle, and then we spray painted the wheel a forest green. Originally, we were using a wooden dowel as the axle, but when we tested this, the wheel didn't turn. In response, we used a drill to create a bigger hole. However, this still didn't work, so we decided to try using a smaller axle. In trying to determine what we could use as a smaller axle, we realized that the stems of the flowers we used to decorate might work. Using this, along with modifying the water flow rate by adjusting the power of the pump, was exerting. Our wheel began to turn constantly. This completed our design cycle. As you can see, we had to complete the design cycle multiple times as new problems arose in order to arrive at our final product.
The two biggest challenges we faced in building our fountain were adjusting our plan of how the water would flow when we realized we could not drill through the trunk, and problem solving to figure out how to get our wheel turning. Both of these challenges went through their own design processes in order to become a solution. Unfortunately, we did not place at Fed. We think our biggest issue was that we didn't realize the scope at which other groups would build their fountains. In hindsight, we all wish we would have looked at past projects before starting ours, so we would have had a better idea on how big our design should have been. We also wish we had thought bigger from the very beginning, because once our materials were bought, especially our basin, we were somewhat locked into the size and scope of our design.
Okay, so my advice would be to definitely start early, start thinking of ideas early, because the first milestone comes up a lot faster than you would think. And to not be afraid to think really big from the beginning, not to be deterred that you don't know how to do anything yet. Just go big or go home. And that's my advice.
Hey, my name is Tony. So some advice I would say is the most important part is research. You really need to look into a lot of the developments that have been made. It can really improve the solutions and the ideas you can come up with. And obviously the more ideas you come up with, the better idea you end up with. So if you can start that early and really develop, as many ideas as you can, it'll really help the process in the future, and you'll make a really awesome project.
Hi guys, I'm Lexi. My advice would basically be to start early. Definitely make sure you have set meeting times with your group every week so you guys get ahead and stay ahead. And also, don't be afraid to ask for help. There's people available to you like the guru and people in the makerspace that can help you, so you don't have to do this project all on your own. So reach out to people.
Hey guys, my name's Alay, and I have 2 pieces of advice to give you guys. The first one is that you should always start early because it helps know what you're doing and not wait until the last moment and working 12 hours a day. And then the second thing is that you should use your resources wisely because you get $40 to use, and it would help to not spend $20 on one piece of equipment when you can buy it for $5. So looking at the prices and using them wisely. That's basically all I have to say.